Okay, we're going to go over number 13 on the sample final. This is also a problem that was on your quizzes dealing with dilutions and dilutions with reactions. So it tells us the H plus concentration is 0.15 molar in a final solution that is made by mixing 25 milliliters of 0.75 molar HClO4 and 75 milliliters of NaOH with an unknown concentration. It wants us to solve the unknown concentration of NaOH. It gives us a reaction here of H plus OH minus makes water. The key to this problem starting off is to realize that it's a limiting reagent problem along with a dilution problem. It tells us the H plus concentration is 0.15 molar in the final solution. So if H plus is left over at the very end, then that's telling us that H plus is our excess reagent, where OH minus is our limiting reagent. That means that OH minus is going to be all used up in the reaction. Before we start, we can figure out our new total volume. Pretty simple. Add 25 mils plus 75 mils gives us 100 milliliters for our new total volume. So let's quickly figure out how we're going to find these different pieces of the puzzle. So our moles of NaOH is going to equal our moles of OH minus. Why? Because we have one OH per molecule of NaOH. This is also going to equal the moles of H plus reacted. Now, why is this? Because it reacts in a 1-to-1 ratio in our equation. The next step is to figure out moles of H plus reacted. That's going to equal moles of H plus initial, what we start with, minus moles H plus left over. So let's figure out our moles of H plus initial, and it tells us that we have 25 milliliters. Now we don't want it in milliliters. You want to get it in liters whenever you're dealing with molarity. It tells us the concentration up top here is 0.75 molar. We're going to write it as moles per liter. That is the key to solving these guys. And it's HClO4. We want moles of H plus. It's just a 1-to-1 ratio. 1 mole of HClO4 for 1 mole of H plus. So that gives us 0.018 sig fig line 75 moles. That's our moles initially. Let's figure out our moles left over. It tells us again a concentration, and we already have figured out a volume. We had 100 milliliters for our total volume by adding 25 and 75. course, we're going to get it out of milliliters. We're going to put it into liters. And okay, I don't know what happened there. Let me erase that real quick. Go back to my drawing. Okay. And our concentration was 0.015 molar, or moles of H plus per liter. So our moles left works out to be 0.0015 sig fig line moles. Remember, to figure out our moles reacted, we got to know that it's moles initial minus moles of H plus left. So let's subtract these. Moles initial 0.01875 minus left 0.0015. And that works out to be 0.017 25 moles. So that calculation, again, to remind you, was moles of H plus reacted. So our last step, like we said up here, the moles of H plus reacted, remember we said it right here, equals the moles of OH minus reacted. So we have 0.01725 moles of OH minus Now remember, our OH minus came from an unknown solution of 75 milliliters. So now we got to use that 75 milliliters of volume, but we're after molarity, which is liters, so we're going to put it into liters. So now we have moles of OH minus per liter, which is molarity, works out to be 0.23 molar. 2 sig figs, of course, because we've been keeping track of our sig figs via our dotted lines. So it's an extensive problem, puts together dilution concept, puts together limiting reagent concepts, and of course knowing how to do mole ratios. So this is sample final number 13.